This is Mr. Hanna, and welcome to What the Format. Today we're going to go over an algebraic proof. So I have two videos that talk about the properties of equality. We're going to use those today. I'm going to show you how to use them. Now, normally in algebra, when you do your steps, you show your work. In an algebraic proof, you show the result of your work, not your work itself. So if you need to write it out to the side so you can see the steps, I highly recommend that. Okay, so for here, right here, recall that distributive property is when you have a number next to parentheses and some numbers inside the parentheses. That's your key. This says we're going to use the distributive property. So when I do 2 times x and 2 times 7, I get 14. We leave the other side alone for now. Why is that? Some students are always saying, well, wait, I can add the 5x and 3x. Yes, you can. But in algebraic proof, you have to describe your steps. Now, the first step, what you start with, what is on the test or teacher puts on the board or in the book for homework, that is given to you. So our justification for that being true is given. Okay, almost all proofs start with that. Now there are some exceptions, but generally speaking, if you write down what you're given and put given, you're good to go. Now, we use the distributive property there. So our justification is distributive POE. Remember, POE stands for property of equality. We don't want to write that over and over again, so we abbreviate it. Now, we want to add the 5x and 3x, but technically you can't. They're not right next to each other. Addition, subtraction, in order of operations, goes from left to right, okay? And so now some of you are thinking, well, I've always done that. Is that wrong? No, it is the right thing to do, but now we got to justify why we did it. So we rewrite this. We don't touch this side. And now we rewrite this as 5x plus 3x minus 16. Those traded places, they moved. Remember, that's the commutative property. Okay, so we're going to write commutative. Now, if I put parentheses around these two, okay, and maybe made this negative 16 plus 5x plus 3x and had the parentheses around the negative 16 plus 5x, and then the parentheses moved, so I added the 5x plus 3x. Instead of using the commutative property, I would have used the associative property. Why is that? Well, because, again, the parentheses would have moved. Let me demonstrate that. So, at this point, I used the commutative property because these moved, okay? Now, if the setup had been different, you would have had this, negative 16 plus 5x, but you've been given that with parentheses, okay? Then what we would have done is we would have changed it to match, and then we would have had this. This would have stayed the same, remember, because we're only doing one step at a time. And then we would have had this. Okay, so that right there is now the associative property. Okay, because the parentheses moved, the numbers stayed the same. Okay, see how the parentheses moved? So there's, in the same example, depending on how they start, one had to use the commutative property. This one has to use the associative property. Now, you don't determine that. That would be decided in the problem. These would have been two different problems. I'm just trying to give you an example of each one without making the video too long and making it too complicated. So hopefully you saw in the first one, the way it was written, the 5x, the 3x, and the negative 16 moved. Since the numbers traded places, that was commutative property. And now because the parentheses are moving, this is associative property. Now we can keep going, because now, of course, we're going to do what? We're going to add those. We're actually going to do the math. Okay, now that is called CLT. CLT stands for combine like terms, okay? That's the normal algebraic thing that you've done all the time when you combine your numbers or your variable terms that are the same. It's called combine like terms. Another way they'll say it there, maybe you just say simplify. Some teachers like to simplify their combine like terms. They're essentially the same thing. Okay, so now what am I going to do? Well, I want all the x's on the same side. Okay, so negative 2x, negative 2x. I'm subtracting here. See, to add that 16 over is addition, so I can't do them in the same step anymore. Okay, so that right there is, I'm showing my work. We don't do that in algebraic proof, but now you see what I'm doing. That's going to give me what? 14 equals negative 16 plus 6x. Okay, so I started to show my minus 2x so I could see what I was doing. Now I actually just do the work, but I erase showing the work. Now I justify the step. I subtracted 2x from both sides. That's the key. Now that's your subtraction POE. So now I need to get the 16 on the other side. So now I'm going to add the 16. There's my 30 equals 6x. And so now that's the addition POE. So all I'm doing is saying what rule, what my justification was. Now normally in algebraic proof, I should have said this at the beginning, you have your S and your R. Okay, S is for your statement. And it's not always an equation. It could be, you could say, oh, triangle ABC is a right triangle. Well, how do I know that? Okay, then you put the reason how you know that. Okay, R is your reason. Why is this statement true? Why could I do these things? There you go. Now, you can see we're not done. We have to divide by the 6, since we're dividing both sides by the same thing, and we're going to get 5 equals x. Up. Made the same mistake again. See, I'm so used to doing algebra. Forget. It's easy to forget that. You're just going to write 5 equals x. Okay, we're dividing by the 6. And how is that possible? Division POE. Now, we normally like the x on the left. You know we can switch them. That actually has a name, symmetric POE. If you want to use that, you can. Otherwise, up here, what we could have done, we could have subtracted the 8x over here. That would have put our x on the left side. Okay. Now, maybe this is a little confusing at this point. You're like, wait, there's different things I can do. Sometimes the proof can be written 2 different ways and it still gets you there the same way. But it's just like driving. You can start at the same place, go to the same place, but one of you might take one route, another route. As long as the roads connect you from your starting point to your destination, okay? From where you start to where you're wanting to end, okay? As long as the roads connect you, it's okay. And yes, sometimes there's more than one way to do it, but sometimes there isn't, okay? Distributed property, there is no substitute for that, okay? And one, you have to distribute typically I say, because sometimes you can divide by the 2. Now in this case, we couldn't divide here because we had all this stuff over here. See, so sometimes they force you to do distributed property. In this case, we did. Other times you could modify that. How do I know, Mr. Hanna? Well, you have to do lots of problems and practice and play with it. There's really no other way. So what you do is you just write out a bunch of 2-step equations, practice solving them. Those will be just using your subtraction, addition, multiplication, division, POEs. Typically, then you start adding things like distributed property, community. You just start playing with it. Okay? Yes, that takes some time. It's not necessarily fun, but that's how you learn. You don't learn by doing one problem or 2. You have to do multiple problems. You have to ask questions. Okay? This is a general one. Now, of course, notice I didn't actually get the multiplication POE in here. I could have changed that as if this had been a fraction. So if we do one of these in a way that you add x over a number, then the multiplication POE would come in. See, all the different things to look for. You don't always use everything on the same proof, okay? And in this one, I actually used a lot of things. I made it a little bit more complicated. Why? Just to demonstrate all the steps. But of course, again, that depends on the problem you're given. There could be 2 steps. There could be, sometimes I've seen proofs with 1 step. Just that simple. Others I've seen with anywhere from 10 to 14 steps. It just depends on the complexity. It's like driving. You know, sometimes you're driving a short distance, sometimes, and you just take, like, oh, take a right turn here, follow this road, boop, I'm there. One thing. Other times you have to follow all sorts of roads. But anyway, this has been an example of algebraic proof. I hope this helps. Thank you for watching What the Format. This is Mr. Hanna. Happy mathing.